Day 40, Honors Physics, Energy, Conservation of Energy, Problem 23. Once again, this problem is much easier done with conservation of energy than it is with kinematics, especially because of the fact that we have some energy lost here. The acceleration is not 9.8 meters per second squared. It tells you we've got energy loss. So I've drawn a diagram. You have three positions of interest. Point A, the point of launch, assuming it's from the ground level, not above the ground. Goes up to the top, point B, and then it lands at point C, ground level with A. Maximum height, 20 meters. So the first thing you want to do in this problem, step one, is to figure out the GPE at point B relative to the ground, because they give you how high it is. So you take your M times G as 10 instead of 9.8. So I'm getting a 1 sig fig answer for the energy at point B, 8 joules. I'm playing a little bit loosely with sig figs here. Well, it tells me that in part A that we've lost 1 joule of energy on the way up. So you make a deduction that therefore it must have had 1 more joule of that on launch at point A. So 8 plus 1 is 9. So the ball left the ground with 9 joules of energy because it lost 1 joule to air friction on the way up. So then you just plugged it into the kinetic energy formula, 1/2 mv squared. Going back to 2 sig figs now, the velocity at A is 21 meters per second on launch. So it goes up from A to B, stops at B, and we'll have a 0 velocity, but the energy has dissipated. We've lost 1 joule of energy to air friction, the work done by air friction, 1 joule. All right, well now, step 3, compare point C to point B. It says in part B of the problem, if we lose the same amount of energy going down, in other words, you lose another joule of energy at the top at point B. If you had 8 joules, that means you have 7 joules of energy at point C. And once again, just plug into the kinetic energy formula and solve for the velocity at point C, which is 19 meters per second. If there was no air resistance, the ball would come back to that same location at the same speed it was launched at. But now it's slightly less because of losses due to air resistance.